Hi guys, so this week we've been looking at exponential decay, and we looked at decreasing sequences, we've looked at half-life, we have also looked at declining sequences. And so one more type of declining geometric sequence we're going to take a look at for exponential decay is depreciation problems. Okay, so what does depreciation mean? Depreciation means to lose value each year. Cars lose value, sometimes homes lose value. If you buy electronics, they depreciate, they lose value. So you may have heard that before, that a new car loses a large part of its value in the first 2 to 3 years and continues to lose its value, but more gradually over time. That's because the car does not lose the same amount of value each year. It loses approximately the same percentage of its value each year. What kind of model would be useful for calculating the value of a car over time? So we're going to use an exponential decay model. So we're going to look at this example. You buy a new car and its value is $20,000 and it depreciates at a rate of 20% each year. So when it says it depreciates at a rate, that means that the value goes down 20% each year. So if it loses 20%, then how much is it keeping? It's keeping 80% of its value. So what's the initial value of the car? The initial value of the car from the question is $20,000. That's how much you paid for the car when you bought it. What is the percent of depreciation? So we already said that this car is losing 20% each year. So we have to find out, okay, well, what's the common ratio? So like we said up here, if it's losing 20%, it's keeping 80%, so our common ratio is 0.8. Or we could just do, it's 100% minus 20%, and that's where we get the 80%. So our common ratio is 0.8. So let's take a look at the depreciation value over a 5-year period of time. So to get from one term to the next, since we're keeping 80%, we're multiplying times 0.8. If we multiply 1,600 times 0.8, we're going to get 12,800. So at the end of the second year, it's only worth $12,800. Multiply that times 0.8% at the end of the third year, it's worth $10,240. Multiply that times the common ratio of 0.8, and it's worth $8,192. Multiply that times 0.8 or 80%, and at the end of year 5, the car is worth $6,553.60. So if we wanted to write an explicit equation, by explicit we mean a y equals equation for the value, to calculate the value of the depreciation for any year, or the value of the car for any year, then it's going to be our initial value, which is A, and then 1 minus the percent rate of depreciation. So it's depreciating by 20% each year. So when we do that, our initial value is 20,000, and again, since it's losing 20%, it's keeping 80%, and then x is our exponent, where x is the number of years. So we're going to use this equation to find the value for the car at year 8. Well, year 8 means that our x equals 8. So y equals 20,000 times the 80% that we're keeping to the power of 8. And when we do that, we get $3,355.44. That's a pretty neat number. So at the end of year 8, the car is worth $3,355.44. So next question, letter F, when will the depreciated value of the car be worth $5,000? So this is where you have to put this equation, let's go back over here, put this general equation right here into your calculator, look at your Y list to determine when is Y equal to about $5,000. That's what we're looking for. That's the question we're trying to ask. So if we go on your calculator, look in your Y1 list, it's somewhere between 6 and 7 years, and if we wanted to be specific, it's about 6.2 years. And again, you have to use your calculator for that. Okay, now's the time where you might want to pause the video. It's your turn. Take a look at question 2. Matt bought a new car at a cost of $25,000. The car depreciates approximately 15% of its value each year. What is the percent rate of depreciation? What's the common ratio? What's our explicit equation, our Y equals? And what will the car worth be in 10 years? So pause the video and then replay it to check your answers. Okay, so at this point, your answers should be, what is the rate of depreciation? It's depreciating by 15%. As a decimal, it's 0.15. What's the common ratio? So if it's losing 15%, it's keeping 85%, so our common ratio is 0.85, 85 hundredths. Our explicit equation, here's our start, $25,000. This is the percent we're keeping, which is 85% of the value of the car each year, and X is our exponent, where X is the number of years since the new purchase of the purchase of the new car. So what will the car be worth in 10 years? That's where X equals 10. So take our equation, 25,000. Again, we're keeping 85% to the 10th power, and after 10 years, the car will be worth $4,921.86. Okay, now it is your turn to answer these questions. A $10,500 investment has a 15% loss each year. Write an exponential equation to model the decay of this investment. So keep in mind, it's losing 15%. How much is it keeping? After you find your equation, right here, determine the value of the investment after 4 years. It's losing 15% each year. What's it keeping? And so when X equals 4, how much money will we have in this account at the end of 4 years? Round your answer to the nearest hundredth. And then go ahead and put your answers in the Google form. And if you have any questions about tonight's homework, you can put your questions in there as well.